Charles' law is one of the gas laws that we need to look at. Charles' law says that the volume of a gas is directly proportional to its Kelvin temperature and extrapolates to zero at 0 degrees Kelvin. The temperature has to be in kelvins because that's where the proportionality is. And if you think about this, so let's say that we had a balloon and we took this balloon that we'd filled up with air and we put it in the freezer. And overnight, as the temperature got cooler, what would happen to the balloon? Well, it would get smaller. And if we took the same balloon and heated it up, it'd get bigger. So the formula to calculate it is V1 over T1 is equal to V2 over T2. Again, the temperature is in kelvins. The volume can be in whatever it needs to be as long as it's the same volume units. So if we look at our sample problems and we look at the first problem, it says a sample of nitrogen occupies a volume of 250 milliliters at 25 degrees Celsius. So our volume 1 is 250 milliliters and temperature 1 is 25 degrees Celsius. And temperature 2 is 95 degrees Celsius, and it's asking us to solve for volume. So that's going to be V2. So rearranging our formula, we can say that V2 is equal to V1 T2 over T1. Now it's important to remember, again, temperature needs to be in Kelvin, so we need to add 273 to each of our temperature units that were given because they were in Celsius. And also we just need to remember when we do these that keep your volumes and your temperatures together as you read through the problem. So by substituting our values, we can say 250 times 368, that's the second temperature, divided by 298, and that's going to be equal to 309, and the unit was milliliters, so it's 309 milliliters.